Hello, in this video we're going to be talking about rate times time equals distance, hence RT equals D. So I'm going to read through the problem and we'll go ahead and get started. The Flash was speed walking out of downtown Charlotte at a speed of 20 miles per hour. 3 hours later, Supergirl left downtown Charlotte to catch up with the Flash. Supergirl was flying at a speed of 50 miles per hour. How long will it take Supergirl to catch the Flash? So in this problem, hopefully we can see that we have two individuals who are basically racing that we're talking about. We have two races, we have a time frame, and we can calculate their distance. So in this problem we have the Flash, and then we also have Supergirl. So I'm going to go ahead and start our rate times time equals distance table. So we have our rate, and we're going to multiply that times our time, and that's going to be equal to our distance. So I'm going to draw our little table. And if you notice, I have two rows. One row is going to be for one individual, and the other row is going to be for the second individual. So I'm going to have the Flash, and then we're going to have Supergirl. So as you look, the first column that we need to fill out is their rate. So in this problem, we're going to look at their rate. So in this problem we're actually talking about speed, which is a rate. So the speed of the Flash, speed walking out of downtown Charlotte, speed of 20 miles per hour. So we know he is going 20 miles per hour. So I'm going to go ahead and put 20. And then when we look at our second person, which is Supergirl, we can see that Supergirl was flying at a speed of 50 miles per hour. So we know Supergirl is going 50 miles per hour. So I'm going to put 50. So as we're looking at this, we can clearly see that Supergirl is going a whole lot faster than the Flash. We also know that from this problem we can clearly see that Supergirl left 3 hours later, meaning that the Flash started first. Meaning he had a head start. And we can see that he had a head start of +3. So he runs for 3 hours and then she goes. So when we're talking about time and we're trying to answer the problem, it says how long will it take Supergirl to catch the Flash? So we don't know that. That's our unknown. We don't know how long it will take Supergirl to catch Flash. And how long in this reference is referring to time. So we don't know the time frame that it will take Supergirl to catch the Flash. But we do know however long Supergirl ran, we know that Flash had additional 3 hours. So if Supergirl ran for 10 hours, we know since Flash started first, we have to add 3 to it. So that means if Supergirl ran for 10 hours, Flash ran for 13. If Supergirl ran for 100 hours, we know Flash ran for 103. So I'm going to put X plus 3. And typically, in these problems we're talking about an individual catching up. Typically, one of these time frames are typically going to be your X, and the other one's going to be X plus something, or depending on how you look at the problem, you might have X minus something. So we're going to go on and we're going to actually try and answer this problem. The thing that we have to figure out now is our distance. So when we're looking at our distance, all we have to do is use our equation. Rate times time equals distance. So we're going to multiply our rate times our time. But the thing we have to be careful in this is that when we have a binomial here, we have to distribute. So we have 20 times x is 20x. And then we have to also multiply 20 times 3. Please don't forget this. A lot of people forget, but please don't forget that this is 20 times 3. So this is plus 60. And then we do the same thing for Supergirl. So we have 50 times x is 50x. So now that we have our rate times time equals distance table completely completed or filled out, now we have to figure out what are we going to do with this information. The thing we have to realize that we're trying to figure out when will Supergirl catch up. So as time goes by, she's running a whole lot faster, and then we have the Flash running too, who's not going as fast, and eventually Supergirl will catch up to the Flash. And at this moment that Supergirl catches the Flash, they would have traveled the same distance. They have to be at the same spot, right? So in order for distance to be the same, the key word that we need to look for is when the problem says catch up. So when they say catch up, we're trying to figure out when the two individuals or the two items will be the same amount or the same distance in this problem. So since we're trying to figure out when will Supergirl catch the Flash, we're going to set these two distances equal to each other. So we'll end up with 20x plus 60 is equal to 50x, and then we just solve our equation. So I'm going to go ahead and draw my line. I'm going to move the 20x to the other side, so I'm going to subtract 20x on both sides. We are subtracting because this is addition here and this is positive. And so we know 20x minus 20x is 0. So all we have left on this side is 60. 50x minus 20x is 30x. We divide both sides by 30. And we get 2 because 60 divided by 30 is 2. So let's go back to the problem because I know we have x is equal to 2, but let's make sure we're fully answering the question. So the question says, how long will it take Supergirl to catch the Flash? The great thing about this table is that all our answers are going to reside in this table. So we're trying to figure out how long will it take Supergirl to catch the Flash. So we look at Supergirl and we look at her time. And her time is just x. So we know x is 2. So we know it will take 2 hours for Supergirl to catch the Flash. And that right there would be our answer. But I always like to go back, look at the question to make sure I'm answering the question. It says, how long will it take Supergirl to catch the Flash? And basically it will take 2 hours for Supergirl to catch the Flash. So this is a statement. This statement is a better answer than just 2. How long will it take Supergirl to catch the Flash? 2. If you think about it, it doesn't make much sense. But when I have this statement, it's a little more clear. I really hope this video helped. I guess I'll see y'all next time. Again, this is a live recording from Mr. Smith.